Our next speaker is Davide De Marchi from the Joint Research Center of the European Commission, and he will show us how far you can push Jupyter notebooks.
Yes, thank you. Good afternoon, everybody. I'm Davide De Marchi from the European Commission, in particular the Joint Research Center, located in the northern part of Italy. And I'm really happy to be here. It's the first time for me in GeoPython, and I see a lot of buzzwords that have helped me in all these years programming in the geospatial environment. So STAC, TI Tyler, fair mode this morning. So a lot of buzzwords that will return in my presentation. The Joint Research Center is the Directorate General of the European Commission that is dedicated to the to provide scientific support to the to the EU policy, so to the Directorates General in Brussels. It is quite a big organization, more than 3,000 staff. 2,000 of them are in Ispra, in Italy, in the Lake Maggiore, where I work. But we have another five locations in Belgium, the Netherlands, in Germany, and in Spain. In particular, I work in a group that is responsible for creating an on-premise cloud platform. So a platform that provides cloud services for the researchers and the people working inside the GRC and sometimes in the Commission. This is a broad schema of our infrastructure. We have a hardware layer with machine learning hardware, with processing nodes and storage nodes. We are talking about a petabyte scale platform. So we have more than 25 petabytes of geospatial, mainly geospatial data stored. We have an intermediate layer of that provides large-scale batch processing based on Kubernetes, Docker, htCondor as orchestrator. We provide remote desktop layer so that people can work in Linux, as they are in their own local machine. And in particular, I work in the top of the pyramid in the interactive and presentation layer. So I work in Jupyter. And recently, in the last 3 years, I worked mainly on Voila. So in creating visualization and dashboards that I will show in this presentation. So Voila, for those that do not know, it's a Jupyter extension. It's a Jupyter notebook extension that it's able to create standalone dashboards and applications. It does this in a very simple way, just by rendering a notebook without displaying the code. So just displaying the output of the cells. It is for us, it is a tool that is suitable for communicating the results of research, or complex data sets, or complex teams, topics, even to non-technical experts, because you can create with Voila graphical user interface where the user can point and click to dig into complex data sets or sets of more than one data set that are displayed together. What we like about Voila is that it provides to you the same environment that the data scientists are using. So it allows a data scientist to create a web application. Normally, these two professions are really different because one is concentrated on data, the other is concentrated on front-end development and so on. With Voila, you can be both. You can work in both areas with, I think, good results. Historically, the graphical user interface in a notebook is provided using ipyWidget, which is the historical set of widgets that you can use. It contains elements like buttons, drop-down lists, menus, sliders, etc. It is not so beautiful. It's quite old. So we started to work with something more. We wanted something more. And we discovered 2 years ago that there was an interesting project called ipyvuetify, which was a porting of the Vuetify.js JavaScript library to the Jupyter world. It's a widget library that enables you to make graphical user interface that are more attractive, that are highly customizable. The widgets, you have an enormous list of widgets available that you can customize in every possible way, colors, dimensions, you can manage events, you can do a lot of things. And the most important characteristic of this library is that the widgets are composable, so that you can create complex widgets by grouping simple ones, so that they behave like a single widget, but in reality they are composed by many different elements. And this allows for the creation of very rich user interface. This is just a page taken from the ipyvuetify documentation, just to show some elements. But what we did with the ipyvuetify is we started to create some dashboards. We had a lot of fun with it. And so we decided to generalize it. So ipyvuetify is very powerful, but it's not so easy to use, in the sense that the documentation remains always sends you to the documentation of Vuetify.js. So you have to know JavaScript to use a Python library. So we had the need to create a simplification library that we call Vois. Voice is pronounced like voice in English, like so it has to do with communication, let's say, but it means Voila simplification library. It was created inside an Horizon 2020 project led by CERN in Geneva, and now 6 months ago it was deployed as open source in the code.europa.eu, which is a big, it is a GitLab instance of the Commission where all the public code is deployed and published. And the documentation is here in read the docs. The components of the library, as I said, Vuetify.js is the basic component. Using ipyvuetify, it arrives to Voice. From the mapping component, we use ipyleaflet, which we find very good. We collaborated even with QuantStack to develop some part of ipyleaflet in the past. We use mainly Plotly as a charting library, but in case where the charting that we want to create, the chart that we want to create is not available, we use also SVG, CSS3 and IPy events, and I will show some example of this. What are the objectives of the Voice library? Here is a list. So it wants to facilitate the full exploitation of ipyvuetify with some simplifications, so with using less code. It wants to promote consistent usage of widgets, variants, colors, and themes in an easy way. It allows to create full screen applications without scroll bars. It's the thing that I hate more, having scroll bars in a web application. It supports multiple screen resolution, so it has some function for creating responsive web applications. It enables you to create compound elements, so grouping widgets and composing widgets. And probably the most important, it allows to use layered, what I call layered components. It means elements that pop up from the screen. With ipyWidgets, you cannot do nothing more than what is your rectangle of the screen. With the ipyvuetify and so with Voice, you can have menus that pop up from the screen. You can have dialog boxes that open, other dialog boxes, and so on. So you can profit much more of the rectangle of your screen. So you can put more information. You can give to the user the sense of a desktop application, even if it is a web application. There are specific functions to create multi-page applications, so applications that have multiple views, different sub-applications. There are some visualizations that are specific for geospatial data visualization. There are many charts that are custom-made that can serve as example if you want to make your charts with SVG. And it allows also to exchange the data from the cloud to the local system. I will give some brief example of this. I'm sorry, the text is so short. This is on the right, you see the code that you need in ipyvuetify to create a button with the text, an icon, and the tooltip when you move your mouse over the button. You see it's not so easy, a lot of code. The important thing is here, the button as the children. So this is the composition, the composition function of ipyvuetify. So you can compose in the button, you have a children that is the icon itself. This is the method that you use to compose elements from simple one. On the left, you see the same element created with Vois library. You have a module called button that exposes a class called button where you simply pass the needed elements like the text for the button, the width of the button, the tooltip, the icon, and the callback function. So what happens when you click in the button? So facilitate your work. Consistency. This is an example application to download Sentinel-2 subsets and what was made for African countries where the internet connection is not so powerful. But you see that using Vois you can set some global settings like the color, the most important color of your application, and the fact that the buttons are rounded or not. So some general settings. Just by modifying your setting, like setting the dark mode to true and the color, changing the color first and the button rounded, you see that the application, I show you again, the application changes globally. So it's a way to provide consistent application and to experiment different settings. Vois has the possibility to work with themes, so you can create dark or light dashboards just by setting a Boolean. You can create applications that are full screen. So normally our application have a main bar with the title, with buttons, with icons, with help, whatever you want, and the footer bar with some copyright information. But you can change these settings very easily. But the application occupies all the screen, all the available screenshot. You can do responsive application, like you see here. So application that behave quite well when viewed in tablet, smartphone, or big screens. Here, if you can note, also the text of the buttons changes when the dimension of the window is restricted. Some example of composition, you have in the Vois library like a float range slider, which is composed by a slider and by some values that you can, some buttons that with which you can interact. You can have like a multi-switch element when you want to do a search. You have a single element that is composed by multiple elementary widgets. You can have like a sortable list of elements where you are responsible for the display of the content of each element, and you can change the order of the elements with these arrows, and you can delete elements, you can create new elements, etc. This is an example of pop-ups. I will show this application live. So you have pop-ups that appear on top of your background. You can have dialog boxes, like in this case. You can open dialog boxes where you can put any type of widget. In this case, it is an editor of a vector legend implemented for a web application that I will show later. I will not. You can have multi-page applications, so applications that basically provide a main page where you display some copyright information, the title, some general information, and then with some buttons you can open other pages. You can have how many pages you want. So this is quite. So this is an example of an application for air quality monitoring, and this is a specific page, and you have many different pages that make up the application. You have geospatial function. In this case, this is a trivariate color plate map that you can display very easily. So it's a vector map that is displayed using the values on 3 different attributes. So in this case, it is the percentage of the polygon that is occupied by 3 different crop types. So like arable land, don't remember the name, a permanent grass, and another type of crop. And in this case, this is a bivariate, so you can easily do bivariate visualization by selecting 2 colors, or trivariate, like in this case, where the legend is represented with a triangle having at the 3 sides the 3 colors that you select. When it can happen, we use a lot of charts in our application. I particularly like to put in application a map and a chart that work together, that are linked. So what you do in the chart is reflected on the map and vice versa. But sometimes it happens that you don't have the chart that you have in mind in the library that you are using, for instance, in Plotly, in Bokeh, or Matplotlib. So in this case, we use SVG. This is an example of a custom chart that we did, where we are able to make SVG interactive. So when the mouse moves over these sectors, the highlight of the sector is managed by CSS, so with a simple rule. But we managed to manage the click, so the event. So you click on an element, and something happens in the application. So a Python function is called when you click on an element of the SVG. And this is done using a library that is called ipyevents, which is a small library, but for us it's very important because it enables us to create any type of visualization that we want, even if it's not available in the libraries. Cloud to local data exchange in the library, in the Voice library, there is the possibility to load data from your PC and to save. In this case, I'm loading an example of a legend, and the same, you can save a symbol, you can save a screenshot, you can save a Word document or a PDF, whatever you want, to your local PC. That's it. I hope I have 15 minutes to show if it works. Some demo that we have done. This is the first one. It is a single page application. Sometimes it happens that the research group with which we collaborate creates some data set. For instance, in this case, the unit D5 of JRC created a data set using powerful EI methods to create a crop map. So a map that displays the crop map for each pixel in Europe at 10-meter resolution. So it is quite a big data set. And they published this data set in a paper, and they wanted to put in a paper the URL of the application that can allow the reviewers or the people reading the paper to have a sense of the data set. So in this case, this is a quite simple dashboard, but here you can, for instance, change between two versions of the data set, 2018, 2022. You can, for instance, put the spotlight on a single crop, so common wheat or maize. So you have some simple function. You can change the base map, etc. So I'm working live on it. So what is also interesting here, we have a dynamic tile server that we developed in C++ some years ago. It works still quite well. But recently, we moved to using Mapnik both for raster and for vector data. So we use the raster symbolizer of Mapnik that we find is extremely powerful and very fast to create raster tiles that can be sent to the client. And we do the same in this case. It's not show. I will show you here. Okay. This is another example with a similar data set on the background. And in the foreground, you have a vector data set that is rendered in raster. So the data set, the coordinates are all on the server. With Mapnik, they are rendered as raster tiles, and they are sent to the client. It works quite well with medium-sized data. Of course, if you have millions of records, probably what I saw yesterday, and I was astonished from development seed is really something that we will need to implement. In this case, this is a way to display two different data sets, allowing the viewer to have a sense of both. So a raster in the background and a vector on top. When you go down, the vector is represented just with the borders colored with thematized with the color. Another application that is quite complex is still in development. This is an internal application, so it's meant for our colleagues in Jersey. Since we have this tens of petabytes of data, of geospatial data, it's difficult to search this data. So we need a way for them to go in this enormous data set and see what is available, what can be used for their research and so on. So we created a CollectionExplorer, which is based on STAC, as Vincent cited before. So which is a protocol. STAC stands for Spatio-Temporal Asset Catalog. It is a way to store metadata about geospatial data sets. In this case, I'm just showing you some example of the data set. The STAC catalog is really big. In this case, I'm accessing a 30-meter resolution digital elevation model. And in this case, the dynamic tile server is still a C++ procedure that we developed some time ago. Each data set has its own representation, so it's its own graphical user interface with which the user can interact, for instance, to change the zeta factor so that it becomes a 2D or change the scaling so that the colors are distributed differently according to the elevation, or they can change the color palette, etc. When you are okay, you can add the layer to the map, and you have a map where you can do queries, so you can see which are the elevation, the aspect, and the slope of the points in this case. But the scope of this application is to display more data set together. So for instance, take administrative data like natural earth, for instance, navigate to the items, see the urban areas. Here, just to show you an example of dialog boxes. So you can open a dialog box, probably. F11. Okay. You can open a dialog box on top of your map. You can edit the symbol. You can do a lot of things. You can, for instance, add a marker to the symbol, like. So it's a symbol editor, quite complex, with which you can interact. You can set the scale. Okay, so a lot of things. You can create legends based on an attribute. You can change the color map. Okay. Yeah, probably I use this icon. And so I add it to the map, and I see in the map on top of the raster. So we have some time just to show you that we have also very complex collections, like the Sentinel data, which are in particular the L2A data. I show you that you can, for instance, let's go to Basel. Let's go to Basel. Let's select an interval of dates, like let's go to last summer, so that we have less clouds. We select how many clouds maximum we want, and we say, retrieve me all the images that you have in this interval from 1st August 2023 up to now. And you see here all the images, the blue lines where you have one or more images. And you just click on the calendar and you see the image that is rendered in the viewer. You can change the band combination, like Vincent showed before. So you have natural colors, false color, infrared. You have many types. You have also derived index, like in this case NDVI, which is calculated on the fly. So it is not in the database, in the storage. It is calculated on the fly by the dynamic tile server, where, for instance, you can change the color. So this is the more yellow the pixel is, the more vegetation, the more chlorophyll is in that piece of land. While if it's blue, it's completely non-vegetated. Okay. So add to the map. Sorry. Go to the browsing page, and you see your image. Okay, it's coming. So this is a quite complex application, but think about what I said before. This is a Jupyter notebook. So probably it's something that it's far behind the idea of those who created Jupyter notebooks. This is a real web application that is developed inside the Jupyter notebook. Okay. F11. Okay. I have 5 minutes. I want to I skip some presentation. This is another example of an interesting presentation, of an interesting application. This regards monitoring of air quality in Europe. So it stores a long list of air quality models, and the scope of the application is to evaluate if these models, how fit are these models. For instance, we can select a model on the Pianura Padana, one of the more polluted area in Europe. You can do many things with this data. So you see the model is the raster that you have on the back. And on top, you see the stations that store the pollution data, in this case of NO2, which is mainly produced, I think, by traffic. I'm not an expert. So the scope is to see how fit is the model compared to the observed data, okay? And on the left, on the central part, you have a chart that is developed with SVG, but which is interactive. So you see, you can have a tooltip when you move on the station. You can click on the station and you have the station highlighted in the map, or vice versa. You click on the map and you have the station highlighted here. You have also the fact that when you zoom, the chart is updated, and the number that you see here is a measure of fitness. When it is less than 1, it is okay. When it is more than 1, it is not so good, the fit between the model and the observed values. And one important feature of this application is, for instance, the possibility to import polygons from NATs, so from administrative regions, in this case regions. Let's take, for instance, Lombardia, which is the region where it is most polluted probably in Europe. And all the calculation at this time is done only on the stations that are inside the region. And the important part is that if you change the model, you see now that this the correspondence between the model and the station is quite good. It is 0.97, so less than 1. If we select another model, for instance, one model that covers all Europe, the correspondence is less good, because even considering, again, only the station that interact with the polygon. So a lot of things we should have. I want to show you that we did recently a proof of concept, so an experiment on porting the library and all these dashboards in Microsoft Azure, so in commercial cloud. We first did the test with Hugging Face spaces, and it works quite well, even with the free subscription, so without paying any money. We did the same with Plumber, which is a small cloud based in New York that is providing services for deploying Voila dashboards, and the library works quite well. With Microsoft Azure, it was very good that what we spent is really, really few euro. I was given a budget of 27k euro for 4 months. And in 4 months, with all the development, the experiments, and the dashboard that are there, I spent less than 1k. I spent 800 euro. So it's a viable solution, especially because we have internally, we have a limitation with our platform on serving dashboards that are open to the public. So we are forced to have EU login to access our dashboard. And for some cases, especially for dashboards that are side by side to a paper, it's not so good that you have to register and to insert your account. So in this case, this is an example of application developed in Azure that is completely free. And what I show, it's interesting because I'm using TI Tiler in this application. So this is a way to display in a similar way that I showed you before. So let's select also here up to August last year. Let's select a lower 10% or cloud cover. We can search on planetary computer in this case. So we are using STAC to ask a planetary computer, which is similar to Google Earth Engine, but provided by Microsoft. Here you see which are the images that you have, and you can select an image, and the visualization is done using TI Tiler that was presented before. Even here you can search, you can change the band combination, you can do bilinear interpolation, etc. Last application, it's a real application, simple one, for a project that is called Arctic Passion, where you can see points, station storing PM10 information in the northern part of Europe, and you can interact with the chart and with the map. So also this one is completely free and available on Azure. Sorry, I was too long. Thank you so much.
Thank you very much, Davide. Since the last talk is coming up, I think it won't be too disruptive to allow for some more questions. Do you guys have any?
Does a user, a viewer of the dashboard, has access to the code of the notebook?
No, no. The code is hidden.
Completely, there is some way to show it?
You want I show now or in general?
No. A user, I mean, you have options to allow.
Yeah, if you want, if the user, normally we collaborate with units where data scientists have also programming capabilities. So in that case, we do the development together. So I set up probably we set up the framework of the application. Then we give the code to the researcher. He does some code development, and then we work together into GitLab repository. But it's your choice if you want to give the source code to someone else. Voila is completely hiding the code. The code never reaches the client. The code is only it is only in the kernel, in the Python kernel.
Okay, so it's safe in a way.
Yeah.
Okay.
Yeah. Yeah.
One more question, please. Anyone? Okay, the next speaker is Max Gabrielsson. Thank you again, Davide.
Thank you.